And let's have a little bit of discussion between the dynamic typing system and also the static typing system. So at least many software developers believe that there is certain flexibility provided by the dynamic typing system, and on the other hand, it also increases the burden of testing. For example, there's this blog posted by a group of Dropbox engineer showcase that what is the effort they need to do in order to make sure that the software quality experience is good enough for their internal system, relying on 4 million lines of Python code without type checkings. So, and then of course they have to eventually resort into developing a static type checker running on top of the Python, and at the same time educate the entire software team to accommodate to this so-called the best practice has been developed by the team. Another note that pointed out by famous computer science professor Dijkstra says that testing shows the presence but not the absence of the bugs. So it means that testing, there's always a limit, and there's so much offer but done by the dynamic typing system. So let's take a look at what types and type systems. So in programming languages, a type of a variable or an expression denotes the possible set of values that this variable or the expression might be capturing during runtime. In a type system, hopefully the good one, will ensure that error caused by type mismatching will be eliminated or detected statically or dynamically. So of course, for the static type system, what we hope is that a good one would reject the programs that contains type mismatch during the compilation time, and try to helps us to realize that as soon as possible. But on the other hand, the static type system are not always invincible, meaning that there is always some limitations attached to a static type system. As pointed out by Rice theorem, like all non-trivial semantic property of a program are undecidable. So if we assume that static type checking is also a static program analysis, so there is always a limitation, and it always gives us an approximated result. So that implies that hopefully we can build, when we're building a static type system, we can try to push the boundary, and we are able to identify most of the bad program that are identified as a yield type program. So fortunately, when we're working on Haskell code, the type system of Haskell is way better than compared to others, and it rejects more bad programs and accept more good programs. All the programs on the Venn diagram, so let's say this big red black circle denotes all the program, including the good ones and the bad one. And obviously, if you have a dynamic type language, you can actually pretty much include everything, the good one as well as the bad one. You just need to differentiate the good one from bad one during runtime or during some testing, or eventually maybe the user discover it. On the other hand, for static type checking programs, languages such as Java and C# would definitely reject some of this program, and it rejects many bad ones, while the type checkings, and at the same time, because like I mentioned, is actually approximation, as well as rejecting some of the good ones. And given Haskell having a stronger type system, it actually minimizes the set of the bad one that is accepted by its type system, and at the same time accept more or a bigger subset of the good program by providing much powerful typing features. There are two main challenges or two main tasks that you need to perform. One is that given a syntactically valid program E and the type notation provided by the programmer to verify that the given program and the type notation indeed match or holds. Okay. On the other hand, the second task that a type system often need to perform is to call type inference, that is given a syntactically valid program E, and where in the absence of type notation T, and we try to produce the T such that the T is the right type, the matching with program E. So here comes to the third question, is that what about if the programmer able to produce just the type annotation T, can some sort of system to infer a syntactic valid program E such that the E would match up with the type T? So this related to these another topic called the Curry-Harrod isomorphism, and which is beyond the discussion in this class. And readers or learner who are interested in this topic, you can just do some research on your own.